Let's proceed now with the second part. A sample of 2-methyl 1-butanol has a specific rotation equal to 0.151 and an observed specific rotation for the pure R isomer of the same is positive 5.756. Want to calculate the enantiomer in excess. All right. Now, when we are talking about these enantiomers, let's say the R form, we have got three of them, and then the S form, let's say I have got these. So what happens is when this one is turning plain polarized light to the right, this one is going to be turning to the left and it will cancel. Even this one will cancel with this one will cancel with this one. When we have got equal amount of the R form and the S form, that is going to give us what we call a racemic form, and we call that as meso compound having equal of S and of R. So the rotation that we're going to be able to see here is going to be zero. Why? Because the R is cancelling with S. Imagine someone wants to push you and then someone else is pulling you with the same magnitude of force. So there's not going to be any pull or push. And then what remains here of the S, this is what we call the enantiomer in excess. So the enantiomer in excess is simply the total of the compound, and then you remove the meso compound, or let me say the racemic mixture. So how do you calculate the enantiomer in excess? Enantiomer in excess percentage is given by the observed rotation or the observed specific rotation divided by the specific rotation of the pure substance. Since it's a percentage, you multiply that by 100%. Now, the observed, this is coming basically from the sample. You get the sample, you put in a polarimeter. What you are going to be able to see, in this case, it is positive 1.151. And we are dividing this by positive 5.756. This is in degrees, just degrees, and then okay, we are multiplying by 100%. Now notice that the amount of pure substance, this one is for the R isomer, right? So let's get this. We have got 1.151 and we are dividing this by 5.756, and then we get to multiply by 100%, and this is giving me about 20% if I get to round off, because it is 19.99. So this one is the enantiomer in excess. Now, because it's coming from the R, as we're able to see, meaning that this is the amount of R that is pure, that is not having to be cancelled with by the S. So now let's find the percentage that is made up of the racemic substance. What do you mean by racemic substance? The one having a combination of the R and the S. And that is basically 100 minus the pure one, and that is going to give us 80%. So remember, this 80% is having the R and the S because it's a racemic compound and they're in equal proportions, meaning that the R is going to be 40% and then S is going to be 40% also. So if I want to find out the stereoisomeric composition of the mixture, I'm going to have the R being 40 plus 20, that is 60% R, and then the S is 40%. If we get to add, they should give us 100%. So this is it for this one. Give a mathematical formula relating specific rotation to the observed rotation and define all the terms in the equation. So specific rotation, we have got temperature there, and then we have wavelength. That is going to be equal to observed rotation divided by the concentration multiplied by the length. So this specific rotation is simply telling us if I put this compound, or let me say this mixture, in a polarimeter, how much is it going to turn? The concentration is the concentration of the mixture that I'm putting in the polarimeter, and it should be in gram per milliliter. The length should always be in decimeter, always. The observed rotation is in degrees. Okay. Now, a solution of X, which is a mixture of S, which is positive, and R, which is negative, this should tell us that by R rotating plane polarized light to the right doesn't mean that it always be positive. Depending on the substance, R can also rotate to the negative angles, right? So I've got a sample made by dissolving 4.5 grams of methanol in a volume of 10 mils. So I can be able to find the concentration. The concentration is simply mass over volume because it's basically density. Look at the unit that we want to have. So the mass is 4.50 grams. We divide that by 10 mils. And this is going to give us 0.45 gram per mils. Now we've been given this is in 100 centimeter polarimeter. Then we are going to say we know that 1 decimeter is equal to 10 centimeters. So want now how many decimeters are in 100? So basically divide 10 by 100. I mean divide 10 into 100. And this is going to give us 10 decimeters. Now we want to find the specific rotation of the sample. Specific rotation are the temperature 25 here. The wavelength, of course, we've been given here as being 589.6. Come in. And so this is going to be, all right, so the observed rotation, we can see they've told us this is 22.2, and then the concentration, we've just determined this to be 0.45. Then the length of the tube in decimeters, we have found that to be 10. So then this is going to give us 31.8 degrees. All right, so this is going to be the specific rotation. Now the second one, given that the enantiomeric pure one, which is the S, has a specific rotation of 15.5. Now this is the calculated one coming from the mixture. Actually, my punching, I've gotten another value. This one, 22.2, if we get to divide by that, we are going to get positive 4.93 degrees. Now, if this is the specific rotation of the S form, and we have seen here that the S form is positive, and then we've been given this specific rotation here, which is also positive. We want now to calculate the enantiomer in excess. Now, the enantiomer in excess, percentage E, is going to be the observed, which is basically what we have from calculating 4.93, and then we divide by the one for the pure S, that is 15.5, and then we multiply that by 100%. That will give us now the 31.8 percentage. So what this means, because this is coming from the S enantiomer or the S form, this one is a pure one. So if I remove, this is the S pure, which doesn't have any combination with the R. If I remove from 100%, then that is going to be 100 subtract 31.8. That is going to give me 68.2. So this 68.2 is now the racemic mixture having both the R form and the S form. Now from that R form and S form, we are going to have half being S and half being R. So if I divide that value by 2, it will give me 34.1 being S, 34.1 being R. Remember also have the S, which is pure, that doesn't have any combination. So to this value I'm going to add 34.1. Then I'm going to have this mixture as being the S, and then only the other 34.1 being the R. So what are the percentage of RS enantiomers in the sample? So these are the ones. This is going to be the R, and then this is going to be the S if we get to add those two values. And then just looking at the last question on this part, given the specific rotation is negative 36, what is the percentage composition of the mixture of enantiomer 2-bromo-octane whose observed rotation is positive 18 degrees? Now for this one, we've been given the specific rotation being negative, but the observed rotation is positive, meaning that we are calculating for another form, but we've been given for another form. So here we've been given to say the R, which is negative, has got a rotation of negative 36. And this is for the pure R. But we've been given the one which is positive, meaning that this form they've given us is the S form. It is not the R form. If it was the R form, it would have also been having a negative sign. So therefore, the first thing that I'm going to do, I'm going to calculate the percentage enantiomer in excess. So how do you do that? You use observed. The observed is positive 18, and then divide by the pure. Now we are dividing by the pure R, that is negative 36, and then we multiply that by 100%. And this is going to give us negative 50%. Now, what this means is that, remember, this is negative, meaning it is of the S. So 50% S, pure S. And then if I remove from 100, the other 50 that has remained is now going to be the racemic form. Meaning this other 50, I'm going to have 25% being S and 25% being R. Meaning that the total S in this mixture is going to be 75%, and then 25% is now going to be the R.